Okay, hi guys, welcome. This is a Kafka workshop basically. So I'm gonna be introducing some basic structures and foundations of what is Kafka exactly, how does it work, why is it so popular, some use cases for Kafka. For those who don't know me, my name is Laura Żuchowska. I work as a data engineer here in dyvenia. I'm a computer science major. I've been a part of Guy's research group in my college studies, and my hobbies are art and games. So now let's jump into the Kafka. Uh, what I'm gonna be talking about during this workshop is just some theoretical information about Kafka. How did it get to even start? What's the story behind Kafka? Then I'm gonna jump to the architecture. What are the components of Kafka? Then for use cases, those good ones and the bad ones when not to use it. So we're gonna see both of the cases. And then I'm gonna compare Kafka with other frameworks. So let's jump. What exactly is Kafka? Kafka began to exist in 2011. It was basically made by LinkedIn, by those lovely free people. LinkedIn changed their structure of the application they had from a monolithic one to a distributed PubSub messaging system, which was a major change in terms of engineering, honestly. The first paper was published on NetDB conference, and later during the year, it was open sourced on Apache license. One curious thing about Kafka is obviously the name. As many of you probably know, Franz Kafka was a writer, and asked about origins of the name, Jay Krebs, who is one of the creators of Kafka, basically said that, well, first of all, he likes Franz Kafka, but it also sounds cool generally. And yeah, I agree, it does sound cool. What Kafka is nowadays? It's slightly changed from being just a PubSub messaging system. It also serves as an event streaming platform. It's written in Java and Scala. Initially, it was written just as a messaging queue. Right now, it's used by many companies: Netflix, Airbnb, LinkedIn, you name it, really. It captures data real time and near real time, which is very important to, those are two different terms. It also uses TCP protocol. What is event streaming? So maybe let's jump back. Event streaming is capturing data from multiple sources. So it can be databases, sensors, devices, mobile ones, or whatever, cloud services in form of an event. It also is a storing of those events. And event streaming can also be manipulating those events. So any form of transformation, processing, both in real time and in retrospective, right? Let's speak a bit about the architecture of Kafka. So in the picture here, you can see a general example of Kafka and how is it structured. On the left, you can see that there are producers who are pushing into the Kafka cluster, exactly into the topics. Kafka cluster is composed of brokers, which are made from topics, which are partitioned. Consumers are pulling the data from the topics. And Zookeeper is basically the main guy in Kafka. He keeps track of clusters, brokers, topics. It selects leaders, which I will talk about in a second. It provides all the information about any change in cluster. So whenever there is a fault, whenever something new has happened, a broker is up again, all of this information is handled by the Zookeeper. So that's why Kafka is very fault tolerant. It's because Zookeeper keeps track of everything, every failure of a node, of a broker. It delegates every task to a different component. So whenever something bad happens, Zookeeper is there to handle it. Now let's talk about brokers. So let's go one level deeper. Brokers maintain load balance, and they are sending the messages to multiple topics in multiple partitions. So there's always, a pace. They can process tons, and I mean tons, like thousands of messages in real time for both reads and writes. Brokers are made of topics, which are basically the placeholders for the data. This is very important, as topics are basically the core of Kafka. Brokers also have the leaders. As you can see on the picture, some partitions are colored in orange. This indicates the leader. So this is the leader that the zookeeper has chosen. This partition contains all the data, the instantly directed one, and the followers, which are other partitions in different topics, they are just replicating what the leader has. There is also one follower, which is called an in-sync replica. It's directly in synchronized with the leader. In case the leader fails, the follower that was an in-sync replica can directly take the place of the leader. So there is no way that Kafka can actually fail. I mean, there is, but you know. This is an example of a partitioning. So you can see how does it work. Partition 0 is a leader here. You can see it has like the messages, all of them. The partition 1 has a latency, right? So it has just 3 messages. Partition 2 is even like a further follower, so it has even less messages. So to summarize topics, they are core of the Kafka structure. They are in the middle of a publisher-subscriber messaging system. They are made of partitions, and they serve as the replicas for the data. What is important to notice is records in topics are not being deleted after the consumer has read them. They are being removed from the topic after a retention period. So Kafka is not taking care of did the consumer read the data. This is not the job of Kafka. It just gives a certain period of time for the consumer to read the data. And then the topic is just removing the row. Let's talk a bit about producers. Producers work as a publisher in the PubSub model. They send the data to a one particular topic. There can be more particular topics. The producer partitioner is part of the Kafka. It maps each message to a topic partition, and that producer sends the produce to the leader of the partition, right? The producer can both be a part of Kafka, like directly a part of the Kafka, for example, a Confluent consumer, or it can be a completely separate, different thing. It doesn't have to be in any way connected with Kafka. It can be a separate server or whatever. It just has to have some sort of connection. So it can be a connector, for example, from natively built in Kafka connector. We can use it to create this connection between our Kafka cluster and a certain producer. Important configurations for producers. I just listed the most basic ones. One of them is Bootstrap server. It's basically where Kafka cluster is, so it knows where to connect to. This is an obligatory information. AC case is how many acknowledges does the producer need in order to send another message. So, for example, it's the message about, okay, should the leader just know about the message being sent? Should all the replicas have the message and then producer can send another message? Key serializer and value serializers are just about the type of data that are being sent in the keys and the values. Buffer memory is how much memory can the producer use to send record at once. This value is by default set to 1 megabyte because generally you don't want to send more. This is enough for a one message. A batch size is if you want to send Kafka as a batch, then you can do it and you just pick a batch size you want to send. Consumers, on the other hand, are the subscriber in the PubSub model. They read the data from the topic they are already subscribed to. They use offset as marking the current position in the messages. So for example, when I'm subscribed to a certain topic, I don't want to get all of the message in history forever. I just want, for example, the ones that happened today. This is my offset. My offset is today. So I'm subscribing to a certain topic. I'm getting the messages that happened today. Okay, the next time I'm gonna get messages is tomorrow, right? And the offset moves. So I'm only getting the messages. My offset is marked too, and after. Consumer, just like the producer, can be a totally separate process, not connected with our Kafka cluster directly inside it, or it can be just a built-in Kafka consumer. Consumers can also be placed inside consumers groups. Kafka assigns each partition to one of the consumers in groups. An example of that can be seen in the picture here. This is an example of a topic and messages from before. And we have two consumer groups. So in total, we have 3 consumers, but 2 of them are placed in the consumer group 1. And we can see that the partition 0 and 1 are being sent to consumer 1, and the consumer 2 is subscribing to partition number 2, right? So consumer 1 basically gets everything that's processed in real time, because partition 0 is the biggest one. And consumer 2 is not getting the true real-time information, right? Other important configurations for consumers, very similar to producers. They need to have bootstrap server configured, so the information about the place of Kafka cluster, how to connect to it. Key serializer and value serializer about the type of the message. Is it a string? Is it an int? Is it a timestamp? Group ID, in case we are using consumer groups, we need to send the ID of particular consumer group this consumer is being set to. Also one important one, enable auto commit. This by default is set to true. Should the consumer automatically update the offset regarding to the latest message that was uploaded. Okay, now I'm gonna talk about some Kafka use cases. What is a good use case for Kafka? Definitely activity tracking. This is, I think, one of the best use cases for Kafka. So whenever there is something that we need to track of in real time, that's really process the activities, or like sensors, for example, or marketing. All of the use cases connected with that can be a very good fit for Kafka. Also, real-time cybersecurity. There has been a lot of use cases in that made in Kafka. Internet of Things, so mobile devices. You can also use MQTT, which I will talk about later. And also the Kappa architecture. Those are always very good use cases for Kafka. What's the bad use case of Kafka? Don't use big files when you want to send the big files. I know that you may want to try to send 1 gigabyte video of your cute cat. Kafka will allow you to do it, yes. But should you? Not exactly. You can try using the reference to a picture, video, audio. You can choose an external storage for that, or just send a metadata of your image or video. When not to use Kafka? When you have a very small amount of data, so just few messages per day. You don't need to set up Kafka and everything. It takes a lot to just configure it. You need a license. This is a very simple use case. You don't need to set up the whole Kafka for that. Where also Kafka is not the best choice for hard real-time use cases. So where really milliseconds matter. So for example, in cars that self-drive, right? You need milliseconds there because the accident might happen. Use shared memory instead of directly sending to Kafka. Have a shared memory and read from that. Also, when Kafka is not the best, when you have thousands of clients. MQTT just handles much better a big amount of clients than Kafka. Okay, I'm gonna in a second talk about different frameworks, but first I would like to show you some very basic demo on how to set up your topic and producer and consumer in Kafka. I already have configured Kafka here with Docker and everything. It took some time, so I'm not gonna ask you to do the same because it just takes a lot of time to just set it up. But I already have it started. And so first of all, what we would need to do is to have a topic set up, right? So whenever I'm using a Kafka CLI like that, I always have, first thing is the command. So whenever I'm working on topics, consumers, producers, something like that, it's always Kafka and the name of the thing. What I would like to do is to create, so I need to pass the create flag that I want to create a topic and the name for the topic. So let's open up a fruit shop. reselling fruits now. I have created a topic. I did not create a topic because I didn't specify the Bootstrap server, which is a configuration I wrote in the presentation. My Bootstrap server is on broker with this port because I have it on my Docker file. I didn't do that. Yeah, the typo. Okay, as you can see, I have created my topic, fruit shop. I can list my topics by using list command. I also have to, this time I'm not gonna do this mistake. I need to specify, once again, where is my Bootstrap server? Where is my Kafka cluster? And it will list my topics. Right now, I only have one topic, which is my fruit shop, my amazing fruit shop. So now I'm gonna start consumer. In case I forget how to...
I put my glasses. You click on the right field on the consumer.
Yeah,
Okay.
can I? Can I change the font? Oh, okay. Okay. If I forget the commands, don't worry, it's a simple CLI. I can just type this and it will list me all of the commands and flags. Is it wrong? I don't know. I can see.
The text is not clear.
A bit better now?
Yeah. 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 Do you have a time machine there or what?
I think this is the best we can get.
Okay, so we're gonna create the consumer now. Well, yeah. It doesn't look good, but if you don't change the size of your font in the middle of it, it shouldn't, format like that. But generally, you start the console consumer. You need to pass the topic to which the consumer should be subscribed to. So in our case, it will be not juice, it will be fruits shop. And you need to pass the Bootstrap server. This is just a warning, don't worry. It's because I only have one partition and one topic. That's why it's giving me the warning in case something fails. It's okay that we don't have a leader because this is just for a demo, a very simple use case. In the other window, I'm gonna create a producer. So we're gonna see the messages that I'm gonna produce. So let's start with the producer. We want our messages to be sent to a topic, fruits shop. And once again, we need to specify the Bootstrap server. And as you can see here, now I have an open command line. This is because this is a producer, so I can produce messages, right? So let's say that my customer in my fruit shop bought a banana. And as you can see here, the consumer got the message of a banana. Now he's gonna buy an apple. An apple showed in the consumer. So basically, this is a very foundations of Kafka and how does it work. So yeah, I hope you get the gist of it with this. So let's continue. I'm gonna show some very small comparison of different frameworks. Yeah. Yes, you can. You can also write, as I mentioned in the slide, you don't need to directly have a consumer and producer in the Kafka cluster. You can have them separately and just make a connector. So let's compare Kafka and MQTT. MQTT is very famous. I hope you know it. It's usually used in IoT projects. What are the differences between Kafka and MQTT? One of the most important ones is that Kafka really requires stable network, good infrastructure, while MQTT is okay if you don't have the best connectivity. It's built for high latency scenarios, that's fine. Kafka can handle stream processing and data integration, which is not possible in case of MQTT. Both of those are very scalable, honestly, and high availability. Kafka has a long-term storage and buffering. That's just an information. This is not a comparison or anything. While MQTT is just generally an ISO standard. Kafka has no features natively built for IoT, while MQTT has protocols for IoT projects. Kafka reprocess events, MQTT doesn't. MQTT is lightweight, which is also very nice. Kafka has nice just integration with a lot of other already existing projects and programs. Kafka is not capable of handling well tens of thousands of connections to different consumers, different producers. MQTT has asynchronous processing, so clients can be offline, it's okay. Now, Kafka and Spark. Spark is great, generally. But it's an engine for data processing. It's not exactly a PubSub messaging system, so they work in a different way. So it's important to keep in mind while comparing Kafka and Spark that they are, by definition, different programs. Kafka Streams is one of the capabilities built in Kafka. They can be used just like a library in a microservice, just that, while Spark is a big open source standalone framework. This is also important, not only the way the programs are structured and how do they work, but also the licenses. Kafka is not meant initially for batch processing, it's meant for real-time streaming, while Spark is intended to be batch processed. So this is a very major difference. Kafka can do real-time, while Spark is more a near real-time. You don't need a separate cluster on your machine, on your server for Kafka, while in Spark you need a separate cluster for certain use case. Kafka scales easily. You don't need to reconfigure the Kafka every time you make a change. Well, it's not true in Spark. You have to reconfigure your environment. Processing in Kafka is slow. You generally don't want to process a lot. You don't want to make a lot of changes in the Kafka because it impacts the real-time part very hard, while Spark is extremely fast in terms of processing. It can do really magic with your data and your messages. The last one I would like to compare to is RabbitMQ. Kafka is definitely faster in terms of bottleneck scenarios. It can process thousands of message rows at once, while RabbitMQ generally just stops at 10,000 rows per second. Also, the difference is in between the ACK and the retention period. So in the Kafka, the messages are being removed in the topic after a certain time, as I've mentioned before. In RabbitMQ, it's based on the ACK that the message has been sent. Also, the big difference between Kafka and RabbitMQ is that in Kafka, you have a dumb broker, smart consumer mechanism, and in RabbitMQ, you have smart broker, but dumb consumer. So brokers do not keep track of the messages. We don't know if they're being read by consumer or not. Kafka doesn't care about that. RabbitMQ is actually keeping track. Okay, this consumer has read the message, this didn't. Kafka is PubSub based. RabbitMQ has a lot of, it's on exchange type. It's a different form of message queue. Kafka by default has 1 megabyte limit for message size. But yeah, as I said, you can send 1 gigabyte video of your cat. Yeah, sure. RabbitMQ doesn't have a limit on your message size. And generally, Kafka is better for big open projects, huge throughput. RabbitMQ is better for small scale projects. So, for instance, the bad use case for Kafka that I've mentioned, the one when you just send few messages a day, RabbitMQ will be better. You don't need the whole setup for Kafka. If you just want to send, for a local private time project you do or something, you don't need the whole Kafka. You can use RabbitMQ. That's fine. So to summarize everything, what Kafka is. Kafka is a scalable real-time messaging platform. It's an event streaming platform for massive volumes, big data analytics. It's a distributed storage. It can provide decoupling. It supports various communication protocols. You can replay the data. It's a data integration framework for streaming ETL. You cannot make ETL, but it's a data integration framework. You can support your ETL. It's also a data processing framework for both stateless and stateful stream processing. What Kafka isn't. It's not a proxy for clients, but there are some Kafka native proxies for certain and very peculiar use cases. Kafka isn't an API management platform. There are tools. Yes, there are tools that can help you with tracking of your lifecycle management, the creation, monetization for multiple Kafka APIs, but generally it's not a management platform. Kafka also isn't a database. I know that it can become confused for some people, but this is not a database totally, and it definitely isn't a database for complex queries. So like you can't just use SQL in your database in Kafka. There are some simple things you can do with KSQLDB. However, I do not recommend it as much. It's really built for just basic transactional queries, very simple aggregations for some use cases. Kafka also isn't an IoT platform. There are some Kafka native integrations. So for example, you can combine actually. You can make a project which combines MQTT and Kafka, which can really turn out great for your IoT projects when you use both MQTT for just the processing of IoT and the Kafka for the streaming part. You can really build very nice projects. Kafka also isn't a technology for the hard real time, but this can be said really about many IT frameworks as embedded systems, which are basically the core, are totally different software. So when you want to make a hard real time case for like some very IoT connected use cases, this will be a big problem. But you might also want to make a lot of research when you want to make something like that. And that's all from me. Thank you so much. I hope you enjoyed it.